Good evening, friends. Welcome to the interview preparation session where we discuss about the concepts of data science and related topics. All right, let's start the session. And this is the first question. What's the difference between PCA and FA? Principal component analysis and factor analysis. I'll be waiting for the answers. So the main difference between principal component analysis and factor analysis is the factor analysis used to specify the variance between factors, and wherein principal component analysis is used to describe the covariance between the you know factors or the components or the variables. Yes, Kritik, you're right. And yeah, halfway you're right. Mhm. Now let's go to the next question, which is the different forms of hypothesis testing used lately, no, which are in popular. I'll wait for your answers. Kritik, null and alternative hypothesis are a part of hypothesis testing. They are a part and principles of hypothesis testing, right? All right. So I meant different forms of hypothesis testing, which are ANOVA, right, and t-test and chi-square test. These are different. Few other are also available, but yeah, these are popular hypothesis testing used lately, right? ANOVA is used to compare the mean values of different classes, right? In the same way, t-test is where the standard variance is unknown and the sample size is very small, all right? And chi-square test, this type of hypothesis testing is used to determine the degree of correlation between the categorical variables. Yes, Ipshita, yeah, this is also another form. Yeah, you can say that. Let's come to the next question. So where do we use heat maps? What are the uses? Kritik, could you please make it a little more simple understanding? I mean, towards the data that we are talking about. Yes, behavior. I mean, what specific behavior would that be? All right, it's basically often, very often used to find the correlation of the variables present in the data set. Right, we can have a distinguished you know uh, image of the variables which states the correlation between them, right? Yes, Priyanka, we can compare the correlation of the data. I mean, the columns or features, right? All right, let's stick to the next question. Explain what is regularization and why is it useful. Right, Priyanka. So regularization is a process of adding the tuning parameter to a model in order to prevent overfitting. Right, Ipshita? Right, this is more often done by adding a constant multiple to the weight vector, usually L1 and L2. We also know L1 is lasso and L2 is ridge, right? you could take the inspiration and you could answer it in a certain way, or else you can take inspiration as well, right? And I'll wait for a while before we go to the next question. All right, the next question is, what is root cause analysis? Right, let me wait for the answers to pour in. Right, Ipshita. So basically, you're finding out the root cause of the problem, right, and a relationship to the cause, right? In order to find the exact roots of the problem that has been caused. This is basically also called as a five why technique, where basically you ask different whys, why has it happened, and that sort of questions. It usually is called as a five why technique, but it can be more or less than five, depending upon the problem that has been caused. It was usually used in industrial accidents, finding out why did and how did it happen. But eventually, it is now used in healthcare, project management, and software testing and stuff. Yeah, it pause for a while before we go to the next question. So the next question is, what is statistical power? Ikshita, you're correct. And what can we avoid when we, consider statistical power? All right. So we can avoid uh, type 2 error in hypothesis testing, right? When we consider statistical power, the higher the statistical power is less likely, to make this type 2 error, right? So basically, statistical power is a likelihood that a study will detect an effect when the effect is present, right? All right. Now that we are talking about the hypothesis testing and type 1, type 2 errors, let's also discuss about what type 1 and type 2 errors are. So what is meant by type 1 and type 2 errors? All right, let me you know again talk about type 1 and type 2 errors, right? Uh, Type 1 error is a you know error in a hypothesis testing when the null hypothesis is true but rejected, right? In the same time, type 2 error happens when null hypothesis is false and you fail to reject it, right? Right, I'll pause for a while before we go to the next question. Right, the next question is, what is selection bias? Why is it important, and how can we avoid it? For the answers. Yes, Ipshita. Yeah, you can use random All right. So in general, it's a problematic situation, right? In which the error is introduced by non-random population sample, right? So for an example, if there are 10 test cases, all right, which are split into 60, 20, 15, and 5 different numbers, which are of 4 classes, right? And Right. So there are four equal number of classes, right? So and then it is given to a model, but it makes a false assumptions that uh, the probability of occurring could be the same, which is biased, right? So this kind of situation is called selection bias. Generally, we avoid you know non-random populations sampling in order to avoid this selection bias. But then we can also overcome this by boosting resampling and weighing strategies, right? Correct, Dipshit. Yes, Manish. Yeah, this situation where you actually try to, draw the conclusions, but then when you use a non-random population sampling, like you tend to get this uh, kind of situation. Right. Using a random method, you can avoid this situation. All right. Hope you've noted it off or have a screen grab. Let's move to the next question. All right. The question is that is it possible to do a positional and label based induction for a data frame? Absolutely correct, Manish. Yeah. So the next question is about positional and label based indexing. Right. First, give me an answer. Like, is that possible or not? All right, let me know if you guys have heard about dot iloc and dot loc in Python. Yeah. So yes, it is possible. So by using these function dot loc and dot iloc functions, we can use indexing, positional based and label based indexing. All right. So dot LOC can be used to index based on the location of the element, and the iloc can be used for indexing based on the index of the element. Yes. So it is possible for indexing in Python. We'll wait for a while before I move to the next question. All right, the next question is difference between ordered and unordered categorical variables. Right, Kritik. If you can, would you name it in a different way? What are ordered categorical variables and what are unordered categorical? I mean the different way. Okay, have you heard about ordinal and nominal data? Exactly. So the ordered categorical variables will be having some kind of hierarchy in their set, right? And the salary is high, low, months of the year, right? And the unordered categorical variable does not have such notion. For example, colors, right? Car names, types of loans, etc. Right, let's go to the next question. All right, the next question is between correlation and covariance. Brief description about the relationship between the variables. Right. Let me pause for a while I give the answers. Okay, Kritik. So, what is the rationale behind? Would you like to recheck, Kritik? I mean, you've answered. Maybe that's a different way. No problem. No problem. Perfect, Priyanka. You've given a right answer. So, which one would you select over the other one? Right. So, basically, correlation measures both uh, strength and direction of the relationship between two variables, whereas covariation only indicates the direction, right? So correlation is most preferable when it comes to knowing the data, right? uh, but I don't think like you can use this particular vice versa answer in an interview, right? That's okay. I mean, it's okay to be wrong at some situations, but yeah, you can correct it. Yeah. The reason why I asked to answer is no, you get to know which one is right and which one is wrong, right? All right. Let me pause for a while before I move on to the next question. All right. Let's go to the next question. What is RSS in regression? Spot on, critic. You're right. And would you also help understanding the use? Where is this RSS used? What does it determine? Or RSS stands for a residual sum of squares, right? Uh, it is a sum of the squares of the variance of two data points or different data points. And a residual sum of squares is used to help decide whether the model is a good fit or not to the data, right? It also measures the overall difference between the data predicted and you know the test data and the trained data basically. Or to be precise, uh, the residual is a measure of the distance from the data point to the regression line, right? Right, I'll wait for a while, before I go to the next question. All right, the next question is, how does R square score describe the strength of a machine learning model? Right. So basically, the R square score mainly gives us how perfectly a line fits for a given set of data. Right. When the R square, hypothetically, if the R squared score is 0.73 or 0.85, right? Uh, it means it explains, the accuracy is 73, or accordingly 73% or 85% of the variance present in the given data set. Right, critic. Okay, let's go quickly for a one last question for this session. What are recommender systems? Right, Ipsita. So it is recommender system is a subclass of a information filtering system. Yes, it is meant to predict the preferences and the ratings of the users that would be given to a product such as movie or an item. Yes. All right. Thank you, friends. This is the last question for this session. Hope we had a informative and interactive discussion over here in this past 1 hour. Let's meet in the next class. You have a great one till then. Thank you so much.